class. Today we are doing the review on our similarity unit, which is unit 17. So here is the review. Now it's easy to watch the review, but I'd like you to print off the review and do it with me, or have done the review already and then work through it with me and make sure that you've got all the answers correct. Now, the first questions ask you to state whether or not the triangles are similar, give the postulator theorem that states that they are, the similarity statement, the scale factor, and then if they're not similar, then just the reasoning for which they are not. So with our first triangles, you have all three sides, so you could check the side ratio and make sure they're all the same. Or because I have two angles that are the same, the 59-degree angle are congruent and the 35-degree angles are congruent, I can just test two neighboring ones. So I could try side angle side similarity. That's what I'm going to try, because then I only have to check two ratios out. So I take 6 and put it over. 6 is the smallest side on that triangle, on triangle ABC. And then which of the three sides on triangle DEF is the shorter? It's the 4. So 6 over 4, and then I have to do side angle side. I have to check that out. So side angle side to make sure that I use the correct proportions with the corresponding sides and angles. So 6 over 4 is one side, wrapping this angle here, and then 10.5 over 7 is the other side. So we're going to check that out on our calculator and see if we get the same thing. Is 6 divide 4, it's 1.5. Is that equal to 10.5 divide 7? And I again got 1.5. So yes, they are similar, and that's by our side angle side similarity. And remember that we write that little tilde afterwards. And then the similarity statement would be triangle. We'll do the 59, the angle we don't know, but could find easily, B, and then the 35-degree side is similar to triangle. So 59 blank 35, DEF. All right, so that's our similarity statement. The scale factor is, you can either write it as 1.5 is fine, or you could take your 6 to 4, and then you can write it as 3 to 2. Okay. Also on these, I mean, it's fine if you go, it doesn't say specifically which way to go, so you could say 2 to 3, that's fine, or 0.67. Those are all fine answers. And then we don't have to answer that part because they indeed were similar. All right, the next triangles have two angles. We have a 40 and a 60, and we have a 40 and an 80. So we know the 40 is all right. We just need a secondary angle. Angle A could be similar to angle D. We don't know. Or to E. It could be an 80-degree angle, and let's figure out if it is. And if it is, then the triangles have to be similar because the other triangle has an 80-degree angle. And just because we don't know one of the angles doesn't mean it's the same angle we don't know. This one that we don't know could be 80 degrees, and the other one that we don't know could be 60. So if I take 40 plus 60, I get 100. And if I take 180 and subtract 100, I get 80. So indeed, that angle is 80, which is the same as this angle. So I have two angles that are congruent, and because two angles are congruent, the triangles are similar. So yes, they're similar by angle similarity. And the similarity statement would be triangle, we'll go 80, 40, 60. ABC is similar to triangle 80 is E, 40 is C, and 60 is D. All right. All right, so the scale factor is going to be, when you just get to pick a triangle, so let's pick this one as number 1. You know what? We don't have side measures. We need side measures in order to come up with a scale factor. So we're going to say not available. not available to us, not applicable. We can't determine it. All right, and of course they're similar, so we don't need that reasoning. All right, the next problems, check 3 and 4. Let's see, I'll use blue. So the next two triangles, so we do know that those two angles are congruent because they're vertical. So we have a situation for a possibility of side, angle, side, right? So if it is going to work, we're going to check side, angle, side. And we do have the proper side, angle, side for the other triangle. So we have all of the information we need to determine if they're similar by side, angle, side. So we would take 2, which is this side, and its corresponding side that we know is going to be 6 because 2 is smaller and 6 is smaller, and that's how we know 2 lines up with 6. And we need to determine if that is equal to, our other side is 3, and the other side is 9. So these have been reflected, basically, the sides, to determine whether or not they are similar. We have to make sure we go 2 over 6 is equal to 3 over 9. All right. And 2 over 6 simplifies to 1/3, and 3 over 9 simplifies to 1/3. So those are the same ratio. The two sides have the same ratio. With it being the same proportion, then we would say yes, they are similar by side, angle, side similarity. Awesome. All right, so the similarity statement, we would need to do triangle. Let's see, let's go FJG. So FJG is similar to triangle. Now, F is at the end of the smaller side of the two sides. So we need to go to the end of the smaller side of the similar triangle, H. We'll start with H, and then J, and then I. Okay? Now, the scale factor is 1/3. We figured that out already when we were determining whether or not the sides have the same proportion, or proportional, and have the same ratio, and they did, and it was 1/3. So we're good to go. And we don't need to figure out if not, because they were. All right, number 4, all we have are 3 sides. So we're going to have to try side, side, side similarity. That's the only one we can use here. So we'll need to check if the smaller 5, we're going big to small now, so this is our first triangle. We need to make sure it's always the side that we put on top. So 5 over 4 is equal to, and then we have to take our medium, which is 10, over the medium length side of the second triangle, 8, and make sure that's equal to the largest side, 15, over the largest side, 12. All right, now we can simplify. Can we just simplify them? 5/4 is already in its simplified form, so it's good. 10/8 simplifies to, you can divide out of 2 and get 5/4. And then 15/12 you can divide out of 3 and get 5/4. So indeed, every single ratio is equal, so they are proportional in sides, which is awesome. So yes, they are similar by side, side, side similarity. Okay, so our similarity statement. Now, I like to make angle marks so that I line them up correctly. So what I do is I take 5 and 10 on this side, and I draw that angle 1 arc. And which one is the one that's congruent to it? It would be the angle that's between the smallest and the medium sized. So small, medium sized is that angle there. And then between the medium and big, 8 to 12, is going to be the same angle as between the medium and big side of the bigger triangle, and that's 10 to 15. So at least I have a couple of marks that I can use in order to line up my angles that are congruent correctly in the similarity statement. So we'll do triangle. Ooh, we don't have sides, do we? So let's just put in sides, A, B, C, and D, E, F. So triangle A, B, C is similar to triangle D, E, F. All right. And then the scale factor is 5 to 4, and we already figured that out. And recall, if you already did this and you wrote it as 4 to 5, small to big, that's fine too. Same thing, because it's not specified. And then, of course, they are, so we don't need to worry about the reasoning. Okay, numbers 5 and 6, are they similar? They are, it looks like we're not going to be able to tell. Maybe you guys have already figured this out, but we need side, angle, side, or all 3 sides or 2 angles, and we don't have any setup in order to properly tell whether or not these sides are similar. So we have side, angle, side on this one, that one's good. But with this triangle, we are missing this side right here, which is the wrapped side, which we don't have, and therefore it cannot be determined. And we don't have the side angle side similarity sides given. Okay, so that one we do not know. Now the next one, are they similar, yes or no? Let's see. We have this angle K. It's going to be congruent to itself because these are ones we can separate. Remember, we did that on a few homework problems. So we have K, B, C, and L, K, M. So angle K is the same. All right, on the smaller triangle, we have sides 16 and 25. On the larger triangle, we have sides 18 and 132, because this side of the long side is 25 plus 107. All right, and 25 plus 107 is 132. So those are our side measures, and it helps a lot if you separate. So 16 over 18 should equal 25 over 132. All right, so 16 divide 18 is 0.888, and 25 divide 132 is 0.189. Oh, I did 88 and I meant 18. My bad. Sorry, I didn't see that until now. The whole side is 88. I don't know why I wrote 18. So 16 divide 88 is 0.1818. I can just erase that. 0.181. And that is not the same as 0.189. So this is no, and that's because the sides are not proportional. All right, so there are those problems. Let's see, I have one more minute left on this section. So should we try it? I guess we'll try it. Hopefully I won't have to do anything to stop it suddenly when I get to 15. But okay, so this setup, if they're similar, then we were going to be able to try side, angle, side similarity. Side, angle, side. We have all the correct markings for that. So the angles are congruent because they're vertical, and then smallest 8 over smallest 28 needs to equal larger 14 over 49. So 8 divide 28 is 0.2857, and 14 divide 49 is 0.285. That's the same. So they are similar, right? And it's by side angle, side similarity. Their sides are proportional, and their angles are congruent. So the similarity statement, let's see, we'll start on the smaller side. LVM is similar to triangle, start on the smaller side, UVT. All right, and the scale factor is 8 to 28, which simplifies to, we can divide out a 2 or a 4. We can divide out a 4 and get 2/7. So 2 to 7, and we don't have to fill that out. All right, I'm going to continue with the rest of it on the next video, so just stop this one and move on.